Hello everyone, welcome to my channel. I was working on some analysis, basically uh, statistics analysis and probability. And while doing that, I was thinking like let's create a video out of it, so I can explain you about some of the topics that are important in interviews, as well as like when we are analyzing the data. Statistics is much important for all these things. So without wasting some any time, let's start doing that. Today basically I will be showing you about this type of statistics, like basically what is mean, the median, mode, variance. Why do we need this? Basically, why do we need variance? Why do we need to check variance? Why do we need to check standard deviation, the maximum value and the minimum value, and the interquartile range? Why do we need these things while doing the analysis of some data sets? Why do we need the statistics? We'll go through the steps, and also how we can detect the outliers, basically, which is out of the range, like how we can detect and which method we can use. Like I know there are multiple methods we can use for outliers. Today I will be only showing the jet score method, so we can detect the outliers. Without wasting time, let's begin. So for this, like, I have a data set, and I have downloaded this datasets basically from the Kaggle, and it's about customer spending datasets from the Kaggle. You can Google it and you can download it as well. And here are some basic things, like I have imported a pandas to work on these datasets, and I have like basically reading the datasets and just showing the datasets, basically top 5 rows. Like if we can see here, like the first thing I noticed, why is this t slash like in the columns, like let's remove this one first from the columns. Basically, to remove, we can do the strip of the columns. The most useful way is like if you do the strip on the columns, basically it removes all the tailing spaces in that case. So this is the command, and why we are doing it, these are some basic definitions. So like if I do this one, like, and if I run it, so basically it removes the tailing spaces. Like if we see here, it removes the slash t. Now let's begin with some more useful informations, like mean, what is median, and what is mode. Mean is basically the average. Okay. Also, we will be only looking into this column, yearly amount spent, because we'll be doing the, like you can say, doing the statistics on this column only, yearly amount spent, because we want to know the average, the mean, basically the mean, the median, the mode, all these informations for this column. The first one, and okay, so basically the mean is the average. The average, we have number of values here. What is the average of all the values? So this is the one, like this is the mean, that is 499. 499 is the average of the yearly amount spent. And let's go to median. And what is that median means? Median means basically it's the middle value. It's the middle value of the yearly spent column. Like calculate a median, like median helps us to understand the middle value and is less affected by outliers. Okay, we will come back to the later what are outliers means. Okay, first let's understand the median. Basically is the middle value of the you can say number of values. We have number of values, and the middle value is called the median. Like if I execute it, so the median is 498. Okay, this is the middle value. Let's come to the mode. Mode is basically the most frequently, you can say, values that occurred in the columns set. Like here, mode tells us the most frequently occurring spending value. Okay, if we are referring to this column, this is like the spending column. Like, so it is the most frequently used, you can say, values. Okay, if I check the mode of that column, okay, these are the most frequently spends on the data set, like for this yearly amount spent column. Basically the most frequent values that comes in the data sets, in the data set. And there is one more thing that I got to know, like what is skewness. Okay, like skewness is basically uh, if the mean and the median is not equal, it usually indicates that the data is skewed. Okay, now what is that skewed means? Skewed means basically the data is not evenly distributed around the center. Around the center means the mean. Skewed basically means the data is not evenly distributed around the center. It is pulled more to one side, maybe to the left side or the right side. It is pulled more. Basically it is not evenly distributed. That is the meaning of skewedness. Let's come to the next part. There are some important things. That is this one: variance, standard deviation, maximum minimum values, and an interquartile range. What are these variance, standard deviations are? Okay, if I go to this part, variance basically measures how spread out the data is around the mean. Okay, suppose I have a mean here, I have a mean here, some dots, and basically how spread the data around that dots. Okay, that is the variance means. And let me just comment out the rest of the things. Okay, so this is the number 6290. So variance basically means basically how spread the data is around the mean, and a higher variance means spending values vary a lot from customer to customer. Obviously, like if the variance is high, the spending values will also be high from customer to customers. Like if I go to the next part, what are standard deviation? Okay, standard deviation is the square root, basically the square root of this one, the variance, and it is easier to interpret, and basically it tells us how much is customer spending varies from the mean. Okay, basically it is similar to variance. Okay, and it is a square root of the variance, and it tells us like how much is customer spending deviates from the mean. Okay, if I execute the statement, it basically tells us the 79. Okay, this one. And let's go to the next part, the range. Like if I need to calculate the range, basically range is the max value and the mean value. Okay, if I calculate the max of this one and minus if I calculate the minimum of that column, okay, then I can get the range. And range is also useful in, you can say, to detect the outliers. And one more thing, that is if I execute it for the range, that is 508 is the number. That is you can say if I max value minus mean value gives us this one. Okay, and let's go to the next one, that is interquartile range. Interquartile range basically it's you can say 25%. Okay, basically q3 minus q1. Let's understand what is q1 means. Okay, 25% value below 25% of customers fall. Okay, of all these data sets, the value below 25% we can capture it as q1, and for q3 all the values that's a below 25, that's a below 75%, okay, then we can capture that value as q3, okay. And if I just execute q1, okay, so this is the one, okay, that is below 25%, and for q3 it will be below 75%. And quartile, like interquartile range, basically measures the spread of the middle 50% of the data that will come in between 25% and 75%. That is, you can say, the interquartile range, IQR. That is, you can say, those data don't have outliers, or it is not affected by the outliers, okay. So if I execute this one, okay, not, I have to comment out this one, okay. If I 104, okay, so like IQR means the data that falls under below 25% and below 75%, that is the interquartile range. Hope you got this point. And let's move to the next one, is the basically how we can detect the outliers detection, basically, okay. And also there are some like definitions I have mentioned, like why do you need to calculate the spreads, like all the spreads, like you may say that the variance, then standard deviation, the quartile, interquartile range, why do we need to calculate this? Because like two data sets cannot be same mean, like basically one, like one can be different, and one is basically it can be scattered, and one can be consistent, okay. That's why uh, we need to calculate all these values. Basically this matrix tells us how stable the data is, how much variation we should accept, is there any outliers exist, all these things. These are the things, like when we got some data set, we have to perform the steps to calculate the outliers, to calculate the variance, how data is spread, and all these things together, these informations. Now second thing is the skew. If I go above, skew basically means data is not evenly distributed around the center, okay. We have to check that part, okay. There is one functions that is skew, and one function that is kurtosis. Skew function basically tells us whether data is systematic or leaning to one side, okay. And also kurtosis tells us how much extreme values, basically the extreme values in the sense outliers, has the distribution list. So if I need to check on the skew, okay, if I need to calculate the skew, okay, basically if the number gives us a positive skew, tail on the right, a few high spenders, and if it is like a negative value, that is on the tail on the left, then a very low spenders means you can say spenders from this data set, okay, from this, basically the customer behavior of spending, that is the meaning of basically here it is saying spenders. So just okay, first of all, if it is a positive number, okay, that is on the left, that is very, they are very high, because there are some high customers that spends a lot, okay. If it is negative, they are very low customers that spends very less, that gives us this informations, okay. And if I execute this one, 0.034, this is the data for, you can say, skew. And if I go for kurtosis, so kurtosis means how much extreme values has the distribution list, okay. If I execute this one, this is the number. And if it is greater than 0, heavy tails, more outliers, basically if it is greater than 0, and if it is less than 0, it has very few outliers, right. In this, it is, you can say, it is less than 0, and it has few outliers. The outliers are Basically, I mean to say that data is evenly distributed and they don't have any much outliers. Now let's move to the next one. Basically the important one, how do we detect outliers? One method is that is Z-score. We can through Z-score we can detect. Okay, let's import a Z-score, and Z-score tells us, like, basically this function tells us how many standard deviations a value is away from the mean. Okay, and a positive or negative Z score, a high positive or negative Z score means the value is usually far from the average. Okay, obviously like if your value is like if the number is pretty high and if the number is pretty low, that is positive and negative, basically it is far away from the average. Okay, and if we calculate, let me first. Okay, so I got this data, like I have used here. So this is basically telling us the Z score, and these are the values, 1, -1. Basically these are, they with this data set don't have much outliers, that's why we have small numbers here. And if I need to get the outliers of this data set, then this is the, like, if it is greater than 3, then those are the outliers. So we have two outliers, you can see, for this data set that is greater than 3. So by this way you can calculate the statistics of variance and mean, median, mode, and all these things. Hope this will help. Hope this understands a bit on these concepts, and I will be coming up with some more videos for statistics and other things as well for data science. And thank you. Hope to see you soon.